Hello, the purpose of this video is to review factoring polynomials for our unit test in Algebra Honors here. Now, for the factoring polynomials, we learned about factoring out the common factor. We learned about factor by grouping. We learned factoring quadratics in two different forms. And we learned about factoring special cases. And I will be going through examples of each of these. Starting off with this factoring out the common factor. Now, in here, the long way of doing this would be to expand out each term to their prime factors there. So we have 2 times 2 times 2 times x times x times x. And then the other one would be just 2 times x times x times x times x. And that's 5, 6, 7. All right, now, then we would circle all the common factors. They both have a 2. There's 1, 2, 3 x's here, 1, 2, 3 x's there. So the GCF would be the 2 and the x times the x times the x, which is 2x cubed. What's left over in the first term is just the 2 times 2, which is 4. What's left over in the second term is that x to the 4th power. Now, if you look here, if you remember when we talked about this in class, that the common factor of the variable, when they both have the same variable, the common factor of a variable, the GCF, is going to have the lower exponent of the 2. That's why we have x to the 3rd here. The short way, looking at this, I see 3 and 12, they have a common factor of 3. Oops, I don't want that line there. Common factor of 3. Now, I know we have a common factor of x, y, and z to all three of these. The lowest exponent on the x is a 1, so I'd have an x to the 1, which is just plain x. The lowest exponent on the y's is the 2, so I'd have a y to the 2nd power. The lowest exponent on the z would be the 2 again, so I would have a z squared. And that's my GCF. Then I would divide both of these terms by that GCF, y squared, z squared. Now when I divide this one by it, the 3's cancel, the x's cancel, the y squareds cancel. And then I'd have the exponents being subtracted here. 5 minus 2 is going to give me z to the 3rd power. Over here, I would divide again by 3x y squared z squared. The 3 goes into the 12 4 times. X to the 5 minus x to the 1 is going to give me x to the 4th power. Y cubed minus y squared, so y cubed divided by y squared, you go 3 minus 2 is going to give you a y to the 1. And the z squares will just cancel, so you're left with this. This is the completely factored expression. From this to this is a completely factored expression. Last one here. We got 3 terms. I see a common factor of 3 in the numbers there. I do not see a common factor of x. I do not see a common factor of y, a, or z. So the variables do not have a common factor. So I'm going to divide all of these just by the GCF, which happens to be 3. And that's going to leave me with 3x to the 4th y minus 9a squared plus 4z. And that's my completely factored expression there. So my answers for these are as I am boxing or circling here. Remember, we should always box or circle our final answers. Next, we're going to do some factor by grouping. I already have 2 videos on the factor by grouping, but I wanted to include some in here. All right, now first thing you should do is check to see if there is a GCF. The x does not carry all the way through, so there's no GCF for the variable. 6 has the factors of 1, 6, 2, and 3. 3 does go into 15, but no, and so does 1, but we're not worried about 1 right now. 3 does go in. Does it go into 8? No. So there's no common factor that works through all of them. All right, so at that point, I would group the first two terms and the second two terms. The GCF in the first two terms, just looking at these first two terms, the GCF would be the 3 for the numbers and the x squared for the x there. So I'd have 3x squared. Dividing that first term by 3x squared, I get 2x left over. Dividing the second term by 3x squared, I would get a negative 5, and the x squared would cancel out, so I'd be left with that. Now looking at the second set of two terms there, they both have a common factor of 2. In fact, there's a larger common factor of 4. So I'm going to pull out a common factor of plus 4 and divide both of these by that 4, which is going to give me 2x minus 5, which is nice because now I see I have that 2x minus 5 in both the first term and second term. So this is a factor in the first term and a factor in the second term, which means we can factor out that common factor of 2x minus 5. When I do that, I'll be dividing both of these by 2x minus 5, divide by 2x minus 5, which is going to make the 2x minus 5's cancel, and you'll be left with 3x squared plus 4. This is my completely factored result here. And I can double check it by doing first 2x times 3x squared does give me 6x cubed. Outer 2x times 4 gives me 8x. Inner negative 5 times 3x squared is going to give me negative 15x squared. Last to be a negative 5 times 4, which gives me the negative 20. So that does double check as my answer there. All right, looking at the next one. First, I need to figure out whether I got a GCF, and it looks like all four terms have an even number on them. They don't share the x, so it's just going to be the number we pull out. Does 4 go into all of them? Well, it doesn't go into 10. It doesn't go into 30. So 4 is not the common factor, but 2 is. So we're going to factor out a common factor of 2, which is going to make this 2x cubed plus 5x squared minus 6x minus 15. All I did was divide all four terms by that GCF of 2 to pull that GCF out. Now I'm going to group these things, group these two and group these two. And the first two do have a common factor of x squared. So we pull out that GCF from that first set, and we're going to be left with 2x plus 5. Pull out the GCF from here. I see a GCF of negative 3. So I'm going to pull out a negative 3 because both of those are negative, which makes sense why we pull out a negative. All right, now we get a 2x plus 5. That also helps us see that we do get that matching binomial now when I pulled out the negative. Don't forget there is still that common factor of 2 on the outside of all this. All right, now I'm not done. A lot of people stop there, and that's a problem. You do need to keep going. We still have that GCF of 2 out here. Then we need to pull out the common factor of 2x plus 5. And what's left is going to be the x squared minus 3. X squared minus 3. That gives you the second binomial there. This would be my final answer. And if I do 5 times negative 3, I get the negative 15. 2x times negative 3 gives me the negative 6x. 5 times x squared gives me the 5x squared. And 2x times x squared gives me the 2x cubed. And when I multiply the 2 through, I do go back to that original expression. Okay, in this section, we're going to do the factoring quadratics in the form x squared plus by plus c. The coefficient on the x squared is a 1 in these. Not this one, but we'll explain that one shortly. All right, so looking at these, I start off by drawing the set of parentheses there. I put the x here and an x here because I'm going to have x times x is going to give me that x squared. Then I have to ask myself, what multiplies to give me this? What two numbers multiply to give me 10, but add to give me a positive 7? Because these last two terms would multiply to give me this, but when we do the outer and inner, those last two terms would add to give me this center number. So what two numbers multiply to give me 10 and add to give me 7? Well, I've got the factors of 10 are 1 and 10, 2 and 5. And when you have 2 and 5, add them together, you do get 7. So we have a plus 2 and a plus 5. Not a surprise that these both work out to be positive because we do have two positives in our original expression. Unlike the second example here where we have a negative in the middle and a positive at the end. The only way we can have two numbers that multiply to give us a positive but add to give us a negative is if both of them are negative. So we're going to have an x minus something and an x minus something. Two numbers that multiply to give me 5 but add to give me 6. Well, 5 is a prime number. Its only factors are 1 and 5. And when you do negative 1 times negative 5, you do get a positive 5, and negative 1 plus negative 5 does give you a negative 6. So there is our factored expression right here. So this is the factored expression for the first one, this factored expression for the second one. Now the third one, they're both negative here. The only way two numbers can multiply to give you a negative is if they are opposite signs. One's positive and one's negative. So the only way that can happen and have the sum be a negative is if the larger factor is negative. Remember, when you're adding opposites, the answer is going to have the sign of the larger number. Okay, so we are going to have an x and an x. One's going to be plus, one's going to be minus. Okay, two numbers that multiply to give me 12. Well, factors of 12 would be 1 and 12, 2 and 6, 3 and 4. And that's all the factors. Now, the larger one has to be has to be negative because the middle number here is negative. The larger factor must be negative. And if we do the 2 plus a negative 6, we do get negative 4. So there's our answer, a positive 2 and a negative 6. And that's our final answer here. And when you FOIL 2 times negative 6 gives you negative 12. Negative 6x plus 2x gives you negative 4x, and x times x gives you the x squared. Now this first one over here may look like it's not in this form, but you have to remember the first step should be to look for a GCF. And when you look at this, there is a GCF of 3. And when you factor that out, you're going to get x squared plus 3x plus 2. And then you would factor that part. What two numbers multiply to give me 2 but add to give me 3? It'd be an x plus 1 and an x plus 2. 1 times 2 is 2, and 1 plus 2 is 3. And don't forget the original GCF there. That goes on there too, and there is our final answer on that one. Okay, and this one here, we're looking for factoring quadratics where we have a coefficient in the front that is not 1. All right, so again, first thing we should check is if there is a GCF here. This is an odd number. These are even. There's only factors of 2, 2, and 1. So there is definitely no GCF in this thing. So then what I have to do is I have to start listing the factors of the 2 and the negative 6. So you got 1 and 2 are the only factors of 2. For negative 6, you have, the middle there is going to be negative. We have to make them, they can't both be negative. So one has to be positive, one has to be negative. I'm assuming the smaller one's going to be positive. Now, it could work out otherwise, but I'm going to work with that assumption. So you have a positive 2 and a negative 3 and a positive 1 and a negative 6. Now, I check to see which one of these sets is going to work out to give me a sum of negative 11x in the middle. So if I do 1 times negative 6, I get negative 6 plus 2 is going to give me a negative 4. Now, if I do 1 times 1 is 1, and 2 times negative 6, I get negative 12, which does add to give me a negative 11. So it looks like I should be working with 1, 2, negative 6, 1. Because I want the 1s to multiply, and I want the 2 and the negative 6 to multiply for the outer and inner. So I'm going to get x minus 6 and 2x plus 1. And if you do the FOIL here, first is going to get you 2x squared. Outer gives you x, inner gives you negative 12x, which does add to give you a negative 11. And negative 6 times 1 gives you a negative 6. So that does double check. So this is our final answer on that one. All right, now I should check to see if there is a common factor on here. I see 10, 39, 27. I don't see a common factor there at all. It looks like they're all, this is even, that's odd. Doesn't look like it's going to work out. Okay, so I need to start listing the factors of the A term there, 10, which is 1 and 10, 2 and 5, and that would be it for 10. For negative 27, I have negative 1 and 27. Well, chances are the smaller number is going to be positive. The large number is going to be negative, because we do have a negative over here. This negative in the middle kind of leads us to believe the larger one is going to be negative. Then we have 2 doesn't go in. 3 goes in. 3 times negative 9 would give you 27. 4, 5, 6, 7, 8. No, they're back to 9. So it looks like these are our only combinations of factors here. So let's see, 1 times negative 17 is negative 17 plus 10. That's not going to work. All right, what if I switched around to 10 times negative 17 is a negative 170 plus 1? That's not going to work. All right, 2 times negative 9 is negative 18 plus 8 gives me a negative 10, which is not going to work. All right. If I do 5 times negative 9, it's negative 45, and 2 times 3 is a positive 6. Negative 45 and positive 6 do add to give me a negative 39. So I do have my numbers here, but I want to make sure the 5 multiplies the 9, and the 2 multiplies the 3. So it's going to be a 2x and a 5x. We want the 2 to multiply the 3, so we want to make sure we put that on the outer part here. So that's a plus 3, and the inner is going to be the negative 9, because we do want the negative 9 and the 5 to multiply. Negative 45x, positive 6x gives us the negative 39x. So this is the correct factoring for that expression. This one we're looking at factoring special cases where they're either of the form of the a squared plus 2ab plus b squared, or the other perfect square trinomial of a squared minus 2ab plus b squared. Or they could be the difference of squares where you have a squared minus b squared. Looking at this first one here, we see a trinomial, so it's definitely not in the difference of squares. This is a perfect square. This is 11 squared. This is a perfect square. And the square root of 121 is 11. The square root of x squared is x. 11 times x times 2 is going to give you 22x. So we do have that first form there, which means that this is going to factor into the square root of the first term plus, because of the positive sign here, the square root of the second term, close parentheses, and square it. The second one here, you'll see we do have a perfect square and a perfect square with a minus here. And if we do the square root of, if we do the square root of 9x squared, we're going to get 3x. If we do the square root of 64, we get 8. And if we do 8 times 3 is 24 times 2, we do get 48. So this is a perfect square trinomial, which means that we're going to factor this into 3x minus the square root of the 64 here. That's the square root of 64 for that 8. Square root of the first term for the first term there. And then this whole thing is going to be squared. All right, some difference of squares. When you have a difference of squares, they are going to factor into x plus and x minus. The square root of that first term plus the square root of the second term, and the square root of the first term minus the square root of the factor term there. So x plus 6 and x minus 6 is the answer for this one. Here the square roots are going to give us 5x and 12. So we're going to get 5x plus 12 and 5x minus 12. 5x times 5x, 25x squared, negative 60, positive 60. Add them together, you get 0. It drops out. And 12 times negative 12 gives you the negative 144. So it does double check. So this is your final answer here. These are your answers over here. And I believe, let's got one more screen here. Okay, this is actually it for the review. I hope it's been helpful. If you have any questions, feel free to put them in the comment field there, or send me an email to funk.matthew@brevardschools.org. That's my email address. Feel free to email me. I'll be happy to answer any questions you have.